This is lesson 13. I've already shown you that there are 3 types of maths you will encounter. The first is changing a value, the second is finding a missing value, and the third is illustrating possibilities. The nature of the change that's relevant to these is determined by practical circumstances. Type 1, changing a value in a particular way. To be successful, you have to memorise details about what the change is and why it is relevant. Memory applies here because you are dealing with a fact. Type 2, finding a missing value. This is called solving an equation. Here you use a 3-step technique and repeat it if necessary. This is the most common math style that students encounter. The practical details are often omitted. This is done to focus on aspects of the processing, specifically the change-inverse change relationship. The third type is illustrating possibilities. There's a standard format for drawing a graph. Begin by making a sample type 1 list generated by this change. In practical situations, some relevant possibilities are based on solving appropriate equations. In other words, type 2. These might be starting circumstances, for example. A maths topic is choosing a type of change and looking at examples of it in our 3 styles. We'll now investigate a new topic. This one is relevant to people who work in finance, medicine, population infrastructure planning, etc. Sound difficult? It should not cause any stress because you already know a lot about it, because it's maths. Your approach should be searching for specific details about A, the type of change, B, how to reverse the change, and C, how best to set up a diagram. Our structure reduces the new experience to 3 steps you already have experience with. Your past history smooths the new experience. Now, what is the nature of this change? We can describe it as consistent growth. To begin with, we'll be context-free. When we apply a context, it will mainly introduce terminology. Our first example of growth will be doubling. Starting with the value 1, to keep things as simple as possible, we can generate the following. If we double 1, we get 2. If we double 2, we get 4. If we double the 4, we get 8. In maths, doubling something 3 times is referred to as multiplying by 2 cubed, and that is written as 2 cubed. Other examples would be 2 to the 5th, 32, because 2 to the 5th represents 2 by 2 by 2 by 2 by 2. That is 1 being doubled 5 times. Another example, 2 to the 10th is 1024. Now that's enough examples for us to get the idea. You should make a larger list and put it on the back of your card, because in a maths course these numbers are met fairly regularly. Now for a type 2 case, 2 to the 6th is something. Now here we are evaluating. The unknown is on its own. So we treat the statement as a set of instructions. It says multiply 6 2's together. So 64 is the value we wanted. Here's a more difficult case. 2 multiplied by itself a number of times gives 128. Now here we are solving. The unknown is not by itself. Now one approach we can have here is multiply 2's together until you get 28. Or you can use a calculator. In either case, you will find the missing number is 7. Now, if you are using a calculator, you will need to refer to its instruction manual. But all devices have a way of undoing a process. And it frequently involves pressing an inverse button along the way. Type 3. Use the examples generated earlier and we get this graph that's shown. The input is how many times we do the doubling. The output is the final value we get. Note that it's an ever steepening curve. It's referred to as an exponential shape, and that is typical of growth situations. Note that if we already had the graph, we could have used it to solve the equation in a type 2 question. If we wanted to solve the equation 2 to some power of 64, what is the power? We could refer to a graph. Begin with the result, 64, and find out what the input was. We had to double 6 times. Now, can you fit this on a card? You should be able to if you use the design that I gave you in a previous lesson. And if you do that, you will have a good summary of the topic. It can be developed further, and we will, on the back of the card. Now here we looked at some maths that you may not have been looking at previously. We got an overview of the whole topic very quickly because we had simple examples in the type 1 case and they led to a graph in the type 3 case, and the interrelationship between those 3 types meant that we could solve an equation as well. We'll go on from there in later lessons. I'll see you then.